When designing a battery-powered circuit that requires a higher voltage or more current than a single battery can provide, I can combine batteries together in series or parallel. Many portable electronic devices, like this television remote, use multiple batteries to meet their power needs. When batteries are connected in series, they're linked together such that the positive terminal of one battery is connected to the negative terminal of another. These two AA batteries each have a nominal output voltage of 1.5 volts. The total voltage across batteries connected in series is equal to the sum of their individual voltages. So these two AA's have a combined voltage of 3 volts across them. I like to think of this as stacking voltages, because the voltage at the negative terminal of each battery gets referenced to the positive terminal of the battery before it. Each battery in series works to maintain the output voltage between its own individual terminals. When a series of batteries is connected to a circuit, the same current will flow through all of the batteries, and it can be calculated using Ohm's law with their combined voltage. If more batteries are added to the series to increase the total voltage, the current will increase too in accordance with Ohm's law. However, adding more batteries to the series does not affect the discharge rate for each of those batteries. In the combined series configuration, each of the batteries is providing part of the total charge to produce that combined output current. Therefore, the capacity and current handling capabilities of the combined series of batteries is the same as each of the individual batteries. If I need to increase the capacity of my battery source, I can do so by connecting multiple batteries in parallel, such that the positive terminals are connected together and the negative terminals are connected together. Since all of the batteries are referenced to the same potential energy, the combined voltage of parallel batteries is the same as each of the individual batteries. When the batteries are connected to a circuit, they will provide current according to Ohm's law. So in this example, two AA batteries are providing 1.5 milliamps to a 1 kiloohm load. Since the batteries are connected in parallel, they're working as a team to output that 1.5 milliamps of current. So each individual battery only has to provide half of the necessary electrons to create that current, which means the batteries will last twice as long as one battery would. The capacity of parallel batteries is equal to the sum of their individual capacities. So these two parallel AA batteries will have a capacity of 4,800 milliamp hours. Adding more batteries to the parallel combination adds more sources of charge, and the overall capacity increases accordingly. In addition to increasing the capacity, combining batteries in parallel can also increase the current output capability of the batteries. For example, if I tried to use a AA battery to power a load which had 20 ohms of resistance, that would require 75 milliamps of current. The AA battery is only designed for a typical current drain of 50 milliamps, so trying to output 75 milliamps would overload the battery and its output voltage would likely drop. But if I combine two AA batteries together in parallel, their current output capabilities add together, so they can output up to 100 milliamps, which is enough to power the 20 ohm load. Now, we're not just limited to combining batteries in series or parallel, it's also possible to combine batteries both in series and in parallel. For example, these 6 AA batteries are connected as 3 parallel sets of 2 series batteries. The output voltage of this combination will be 3 volts, which is the sum of the individual voltages of the 2 batteries in each stack. The output capacity will be 7,200 milliamp hours, which is the sum of the effective capacities of the 3 parallel sets. And the combined output capability of the batteries will be 150 milliamps, which is the sum of the individual output capability of each of the parallel stacks. When combining multiple batteries in series and parallel, it's important to always use the same type of battery because batteries with different chemical compositions may discharge at different rates, and that can cause problems. It's also important to use batteries that have the same freshness, because a battery's output voltage changes over its lifetime. Mixing and matching old and new batteries leads to problems, especially when combined in parallel.